Hey, did you know that the very first version of Windows 95 accepted simply 10 ones as a valid CD key? I didn't, and when I was recently installing Windows 98 on an old computer, a friend of mine, John Sawyer, aka JCase on Twitter, told me about it, and that got me curious. How exactly did the serial check of Windows 95 actually work? And why would it accept a very simple key such as 111-111111? Now, while the algorithm is well known nowadays, I thought it would still be interesting to try and reverse engineer the Windows 95 serial check using modern tools, more than 25 years later. Let's start by looking at the serial number dialog. The Windows 95 serial has 11 characters in the format of 3 numeric digits, a dash, and then 7 additional numeric digits. And if we enter 3 ones, a dash, and another 7 ones, you can see that it will indeed be accepted as a valid serial number. And interestingly, we can kind of figure out what's going on just by trial and error. Let's start by modifying the first 3 digits. When we replace the ones with all zeros, it still works. And if we try 001, it still works, 567 still works, 789, pretty much anything will work. Only a couple of numbers such as 333, 444, 555 and so on don't work. So it seems like for now we can pretty much simply ignore the first 3 digits. Next, let's look at the other 7 digits. If we replace it with all zeros, it still works. So even just entering 10 zeros is a valid Windows 95 CD key. Next, let's try some other numbers. 1 doesn't work, 2 doesn't work, 3 doesn't, 4, 5 and 6 don't work either, but 7 works. And after that, 8 doesn't work, 9, 10, 11, 12, 13, 14, 15, but 16 works. And the next number that works is 25. Well, what do all these numbers have in common? Well, if you stare at them for a while, you might notice that the sum of all digits of the valid serial numbers is always divisible by 7 without a remainder. This explains why 7 ones is a valid CD key. The sum of the digits is 7, 7 divided by 7 is 1, and there's no remainder, and so it's a valid key. Pretty simple and relatively easy to figure out compared to more sophisticated CD key algorithms. We didn't even have to reverse engineer anything. Now, I was pretty curious how that check is actually implemented, and especially how the first 3 digits are checked, so I decided I would try to load this setup into Ghidra to reverse engineer it there. But before we can do that, we first need to figure out in which file of the Windows 95 installation the serial number check is actually implemented. For that, I simply took a Windows 95 installation CD, extracted all the cap archives in it using cap extract, and then grabbed for the title of the dialog, Product Identification. And as we can see, we get 2 hits, su-win.exe and setupx.dll. I decided to go with setupx.dll first, as I assumed the actual check would probably be implemented in a DLL. To load it, we can simply drag it into Ghidra. I analyzed it using the default options, and after analysis was complete, I used the symbol tree to take a look at the exported symbols of the binary. And after scrolling through them for a bit, I noticed this function called PIT-validate. Could this maybe stand for product identification number validate? So let's jump into that function, and we can see that it's basically a big switch statement. I studied it for a while, and checking out the different functions, I realized that the switch statement checks the product type of our Windows 95. There are different Windows versions, such as OEM install, retail upgrade, retail full install, and so on, and the format of the CD key is different between some of these versions. To keep things somewhat short, I've already annotated all the variables and function names here. If you're interested in learning more about reverse engineering in Ghidra, check out some of my other videos linked in the description. The PIT-validate function seems to take 3 parameters: the CD key as a string, the length of that CD key as an integer, and the product type as a string. First, the product type is converted to an integer, which then goes into the switch statement that checks our product type. As you can see, we have 2 main CD key checking functions. I named them check retail key and check OEM key. Now, my Windows 95 disk is of product type 6, which is a retail installation. So let's check out the check retail key function. It simply takes the key as the first argument and the key length as a second argument. The function starts by copying 3 bytes from the key into a second string. These are the first 3 digits of our CD key. The string is then null terminated and converted into an integer. That integer is then compared against 7 different numbers: 333, 444, 555, 666, 777, 888 and 999, the numbers that wouldn't pass the check earlier. So it's really just an explicit blacklist for the first 3 digits. Another interesting thing to notice is that there's no check whether the first 3 digits are actually numeric, and so even a serial number that starts with characters is completely valid, As a matter of fact, the dash isn't checked either, so you can just fill in whatever you want. For example, YOLO followed by 7 zeros is a completely valid serial number. After we've passed this check for the first 3 digits, the rest of the key is checked by another function that I called mod7check. This function simply iterates over the last 7 digits of the key and creates the sum of all digits. Once that's done, the sum is checked whether it's divisible by 7 without a remainder, and if that's the case, the function returns true, otherwise it returns false. And that's all there is to the serial number check of Windows 95. The first 3 digits are simply a blacklist, the next digit isn't checked at all, and the last 7 digits need to be divisible by 7 without a remainder. Simple. Now, before we finish, I also want to quickly look at the OEM key algorithm. The format of the OEM key is slightly different. It starts with 5 digits, then -OEM dash, 7 digits, another dash, and again 5 digits. I've linked the decompiled code of it in the description if you want to check it out, but basically the first 3 digits are numbered between 1 and 366, and the second number is between 95 and 03. The common theory is that this is the day and year in which the key was generated. The next digits must be -OEM dash. Then we have 7 digits that use the same mod7 check we saw earlier, though the first digit must be a 0. And finally, we have the last 5 digits, which can be whatever you want as long as they are numeric. I hope you enjoyed this short journey to the past and to see you on this channel again soon. Thank you for watching.